Hearing us live from the NOAA ship Okeanos Explorer. We are on a cruise that's titled Lima Okamoana, which means partnership in sea. And we are on a seamount that is south of Johnston Atoll, almost due south, probably about 100, 120 miles if I'm not mistaken. But we have a sort of a preliminary name for the seamount. It's called Sally Seamount. And before I go into a little more detail on this, we'll go ahead and introduce ourselves. My name is Chris Kelly. I'm with the University of Hawaii Oceanography Department in the Hawaii Undersea Research Laboratory. Next to me is...
And I am Chris Ma from the Department of Invertebrate Zoology at the Smithsonian Institution's National Museum of Natural History. And if you can say that 5 times fast, I owe you $5.
As expected.
Yeah, so we're going to forego any more introductions for the moment because we have the bottom in sight.
So
we'll find some point a little bit later on to make other introductions. Our depth right now is 2,170 meters. We are on a rift zone ridge, sort of a ridge extending out from the northern end of the seamount. And right now our temperature is about 2 degrees Celsius, so extremely cold, of course. Our oxygen is averaging about 2.2.
Stowed hydraulics are stowed.
And what are the little piece of information for those of you who are not on the event log? Our salinity is about 34.6.
A bit comfortable and I get swing arms out, I guess.
Copy that.
So this is Okeanos Explorer. This is what you're seeing is live research video being broadcast from the Deep Discoverer, which is a robot, essentially a sort of an sort of a truck-sized robot with several high-definition cameras that we're using to broadcast what we visualize on the deep sea floor, and we're able to broadcast that via satellite to everyone from our ship to scientists on shore, to those of you at home, and even those of you at home watching this over the internet. And so this is live,
Great. This is
9:47 Hawaiian time, but
just wanted to let you know we
more likely later
bottom,
for you if you're
and
on
wanted
the
to
Pacific
update you on
Northeast
the
coast.
payload, which is going to be 090.
We've currently landed, and we're staring at our beginning research site. What our typical MO is for these dives is we will land first, and as our pilots settle out and orient themselves, we begin. That'll take a few minutes, and then we'll begin to proceed along the slope and look at various points along a transect line that we've established during planning for the dive. And along the way, we will observe different kinds of animals and organisms on the deep sea floor, look at the geology and other types of environmental factors that are of interest in the deep sea. Sometimes we'll discover new species, sometimes we'll find interesting rock formations.
Securing hydraulics now.
It's all a matter of exploration. All sorts of interesting and new things to be found at this depth of 2,181 meters at the bottom of the ocean. For those of you who are struggling to sort of reconcile that into sort of a more tangible number, that's 1,000 meters is about 5.5 Washington monuments. So at 2,000 meters, we're talking about 11 Washington monuments from head to tip, stacked from the bottom of the ocean to the top of the ocean. So it's quite a bit more than 11 Washington monuments.
Okay, I want to line up on 210 then.
All right, as you can see, we're in sort of a mixed substrate here. So we've got enough sediment where you can actually see bed forms or ripples as a result of the current flow down here. They look like they're moving laterally. The direction of the current is predominantly across the screen from the heading that the ROV is currently at. We also have some rock and some boulder formations that are heavily manganese crusted, which was expected because we believe the seamount is quite old, probably dating back to the Cretaceous. I do want to point out that this seamount has never been dove on before, and the reason we're diving on it today is because the Schmidt Ocean Institute's premier ship, the Falkor, research vessel Falkor, was able to get here on its transit back from Guam to Honolulu right around Christmas time and New Year's this past year, and mapped this seamount as well as some other ones that we're going to dive on this trip. We don't dive on any seamounts where we don't have high-resolution bathymetry data, and they actually got data for the seamount, and so we are delighted to be able to dive on a site that no work has ever been done to our knowledge.
Wash leads, this is your pilot. We're on bottom, and we are all set up.
Roger, pilot. So let's start with some corals here, I guess. We've got, I don't know if these are dead or alive, but maybe we can take a look at some of these white branchy things on the rocks.
Oh,
Copy that. Get over. All right, video. You want to come on in, center?
There is a dead sponge stalk to the left. A lot of dead stuff.
These are bamboo coral stalks.
Yeah, so this is a dead bamboo coral. You can tell it's a bamboo, as most of you already know who've been on these expeditions before, because of the way it branches. It's also got these sort of black rings periodically on the branches, as you can see, that are called nodes. And how it branches, in some species they branch right at the node, or you see a branch coming right out of one of those black bands. And on other species you see them branch between the nodes. This looks like it, when it was alive, it was branching between the nodes. And so that's informative to the coral biologists studying this group.
Copy that. Video, come on out.
Thank you very much.
Chris, it's interesting to note on this skeleton we're looking at that
real quick in front
just below that lowest branch, and actually on that lowest branch, you can see there's some swellings, and it looks to me like there's been calcium carbonate deposited on top of the nodes, which would have suggested when this was alive it was very old. And it'd be interesting to learn, we can't learn just from looking at them, but how old are these colonies? When were they here alive, and how long have these dead stubs been sitting here? Hundreds of years, thousands of years? We don't know, but it's kind of interesting that we see so many of the skeletons here.
Yeah, we're finally seeing a live one, and as maybe the pilot can go over and take a look, they could introduce themselves in the front row.
Copy that.
Cameras online.
They're sitting pilot Sean Kennison. We are all from the Global Foundation for Ocean Exploration, or GFOE. I'm going to let everyone else on the team introduce themselves, starting with Navigator.
Hello, everybody. Sitting as Navigator, Fernando Aragon.
Sitting as co-pilot, you have Levi Unima.
And back in the back row in the clipping chair is Annie White.
And in the far front, you got Roland Bryan.
Right, so it's not positive to me that this branched one that's right at the lasers is alive, but we're going to find out in a second. The unbranched one to the left is clear live.
Yes, please zoom at your convenience. Appreciate it.
Video, come on in, dead center.
And yes, it is alive. So
it's alive to me, Chris.
Yeah, so Scott France calling in from the University of Louisiana at Lafayette. Scott, you want to tell us what we're looking at?
Sure. So you've already said it's a bamboo coral. The branching, it was instructive that, oh, wait, no, hold on. This is a primnoid. So this is not what we were just looking at. This is in the family Primnoidae, another one of the very common deep-sea families of octocorals. And one of the ways that we use to identify the Primnoidae right away, exclusive from the bamboo corals, is the pattern of the sclerites, or the scales that cover the polyps. And you just get a kind of an eye for this, and maybe folks who have been watching this a lot are starting to get the eye themselves. But also there's a very regular pattern to the way that the polyps are typically arranged on a primnoid octocoral. And you can see these are in these little whorls. So we have 2 or 3 polyps that are all arising from close to one another, the bases, that is.
It's good now.
This looks like something we've seen several times, Chris, but I'm not certain what genus it would be.
My guess, Scott, is it's going to be Narella. It looked like it had at least 3 body scales on some of the calyces of the body. I think Calyptrophora usually has 2, and it didn't have enough probably to be Candidella. I think Narella is a reasonable guess at this point, but then I'm not sure anybody can go any further.
Certain about
what do you think, Scott?
Yeah, it's a very reasonable guess. I'm not sure who else is on the phone who can back us up on that. But yeah, in addition to the number of scales, whether they're large scales and the number going from the base of the polyp to the top, also the orientation of the polyps is important. These basically, when they fold up, if they're disturbed, would kind of nod the top end down, curl it downwards. That's another characteristic of that genus Narella. And we could also see a brittle star wrapped up on the branch. Chris Ma, I'm not sure if you want to say anything about the brittle star.
Sure. This is an Ophiacanthid. This is a group of brittle stars that we encounter frequently throughout the deep sea, living on octocorals. This one, I believe, is in the genus Ophioplinthaka, which is something that we've seen throughout the area. I think my earliest memory was since Santiago's dive a few months ago. Some of these jumped off of the corals as we approached. This one doesn't seem to be doing that, so perhaps different species. The reason I'm calling it that is because it has the distinct divisions on the disc there. These are quite sharp. You can notice there are also many bristling spines. It's interesting because a lot of the other Ophioplinthaka we've observed usually occur on cleaned branches, and this one is occurring on branches that still have polyps on them. So the coral is still alive, and the surface is still kind of underfoot with all of these nasty coral polyps, when the brittle star could be just living without them.
Yeah, and so Steve Oskovitz from Temple University noted in the chat lab, and chat room, the chat lab, yeah, that's good, great.
The event log.
The event log, whatever, chat room. He'd noted that there's an anemone or zoanthid on the branches too, which we just saw in the close-up, so pretty sharp eyes. Thank you, Steve, for that.
Well, actually, do you want anything more of this?
Pilot, could we take a look at that unbranched coral to the left?
Yes.
It's just off screen. Yep, that's the one. Thank you.
All right, video, come on in.
Oh, bamboo coral.
Yeah, a smaller one in the background too. Maybe a younger one of the same thing. I'm not sure. Scott,
Well, we're zooming in on it.
Yeah.
I can point out one of the differences in the polyps of a bamboo coral compared to that primnoid we just looked at is this one will not have those large scales, and so it's not going to have a very rough appearance to the sclerites, and in fact, to the polyps. And in fact, in this one, you can see those crisscrossing white lines, the body of each of those polyps, and those are the sclerites. They're made of calcium carbonate. They're microscopic in size, and their shape and texture is very important in the taxonomy of all octocorals. And so in this group of bamboo corals that we see very commonly in the deep sea, it's the subfamily Keratoicidinae, those sclerites are always in the shape of needles or short rods or flattish rods, some variation on that theme, whereas in the Primnoidae, they're much more variable. They're usually some kind of flattened scale that has various surface texture and curvature, and it's more like a suit of armor, where here it's like a bunch of needles or rods embedded in the tissue.
I can reset.
Yeah, so Scott, do you have any idea beyond Keratoicidinae? Do you have any idea about possible clade? Looked like some of the needles in between the tentacles were long, maybe not as long as some species.
Yeah, I'm having a little bit of difficulty saying just based on what I'm looking at here. At first, I was going to suggest maybe the D clade. That's just a name that we give to a group of octocorals that could be in the genus Keratoisis. We're still working on that. But that refers to certain genetic characteristics and morphological characteristics, and we're working on the names for them. Another possibility, I don't think this is correct, I was going to say also C clade, but I think those ones have much, much longer needles. I see that Les Watling in the event log is also suggesting D clade, so that is a good possibility. And the interesting thing about that group of bamboo corals is some of them branch and some of them don't branch. And what that tells us is that the overall colony morphology isn't necessarily important in terms of who's most closely related to who. Instead, it's characteristics of polyp, which is why we take the opportunity to get those close-ups and those images.
Science wants at this
so
point.
Thank you to the IELTS video crew for that.
You want
Great, thank you, Scott. We're good for science. Maybe you can move on so you can find something else.
Sure, yes.
So say again,
Stand
science, there's another voice in my ear.
Yeah, sorry, also I forgot to press my button. Yeah, we're good here. Maybe we can move on and see if we can find something else here in this area.
Yeah, copy that.
Thank you. It's like most of these colonies are dead. We're going to see if we can find some more live material. Just because we see a lot of dead colonies doesn't mean there was some catastrophic event or anything that occurred here. These corals are quite old. They're going through their life cycles right in place, and these could be multiple generations of corals that just died, and their skeletons have remained on the rocks over time.
Roger.
So, excuse me, pilot.
Yes.
We are going to be on rock watch here. If you see something that you think is loose, that's not very flat, it's kind of at least got some girth to it and kind of rounder, well, angled, we'll go ahead and grab it if we can.
Girthy and angular and loose. Got it.
Branched coral upper left from lasers. Now straight above lasers.
Straight above.
Candelabra type.
Oh, okay. I see it.
Give a snap, see if it's the same.
Yeah, that one right ahead, left the laser, which I think you're heading for.
Yeah,
that might fit the bill.
Video, go for quick zoom.
Oh, I see. You got a coral here. Okay.
Oh, sorry. Were you talking about?
Oh,
rock?
no. Let's go for the coral. I didn't see the coral. I was so focused on the rock.
Looks like another primnoid.
Yeah, I'd agree, Scott.
Yeah, I think.
How much tether left? We can do it.
Oh, yeah.
15-meter move your way.
Maybe the same thing we saw
210.
earlier, but I'm not sure about that.
Too much movement going in.
Polyps
tighter.
almost look like they're coming straight out from the branches, so it's
Tail.
Can help you out.
That was 20 meters,
Yeah,
correct?
it's so hard
Yeah.
to tell because the polyps, when
Bridge,
they're alive,
doesn't have?
do come straight out from the branches.
There you go, pilot.
Typically, it's only when they're starting
Okay,
to
we're ready down here.
relax
A little
The
bit.
first move would be
themselves when
range
they're
20
disturbed,
meters,
and
bearing
really are they ranging downwards or
210,
upwards.
speed 0.2.
Video, I'll try it again.
Move 20 meters at 210 degrees at 0.2 knots.
Copy that.
Still way too much movement.
Copy.
Sorry, Sean.
That's all right.
I'm trying.
Here.
There's a snail in the upper right-hand corner. Maybe you could get a quick zoom of that as well, please.
Yeah,
Thank
one
you.
sec.
Oh, no worries. At your convenience.
I'm coming down to give you more tether. It's about as low as I want to go.
Yeah, bridge
No,
movement
that's
is
I think what we're going to do is just
Copy,
stick
Bridge,
with
thank you.
Primnoid on this one. It's a little hard to tell.
Looking for
I think
the snail, but
we're
I
Goodwin
haven't seen
video's
it.
good, pilot.
You're happy? Science?
Yeah, and then the rock to the left, what do you think about that?
It's by your left
It's
toe.
got some girth. It's probably rolled down
Video
slope
coming
a
up.
little bit, but if it's got some type of a... Whoa, it does
Ooh, that
have...
might be a little big.
Yeah, okay.
I
Never
think
mind.
it's. Yeah, tad big for
Tad.
us,
Okay, sorry.
but I can use it as a reference for what you're looking for, though.
Okay, great. Thank you. And then where was the...
Snail was over to the right of the coral we were looking at, just next to the rock. But if we're too far away, we can move on.
That's all right. We're waiting for ship move to catch up. Is it on a rock? Or
No, it was heading towards the rock.
Co-pilot, the ship's already
It was
moving.
leaving a trail, so...
Co-pilot
so it was, I
copies.
think it's
I'm
that
looking at
middle
your
one.
sonar. It
If
looks
you're
like
spying the
the-
coral, there's a
I
rock
think
that's
that's the
just
local
behind it.
little guy
That's
here.
just to,
Yeah.
to the right.
Okay.
to the right?
Because it's so flat,
I'm
we're
sorry, to
gonna,
the left.
To the left.
Yeah, it's
All
right. It's in the center. It's sort of in that little sandbar depression. Now it's in the center, slightly off to the right. There's a little brown bit a little farther up. Yeah, it's at the top of the screen.
Towards the top.
Oh, he's on that little rock there.
Yeah.
There he
there you
is.
go.
Do you see it?
He's
Sort of-
to
Oh,
the...
snail.
Yeah,
Yes.
11
Yeah.
o'clock.
Yeah.
Behind. Okay.
So it's a brown snail with a white foot.
Yeah, sorry. Again, I was so focused on the rock, I ignored your request for the snail. I totally forgot about it.
That's fine. Snails should never be ignored. So this is a gastropod or a snail, something
So,
like
yeah.
the type of animal you see in your gardens at home. Snails are often smaller in the deep sea, with one or two exceptions, and but they're all fairly
Sorry.
important, and they do things that
No, that's a
it's
little-
always good
little
to
tug.
watch out for them. Sometimes they're predators, sometimes they're just tridivores. This one has a long sort of the shell has an elongation on the top, which suggests that it might be predatory. So it's hard to say what it might be eating down here, but interesting animals. Okay, we can move on. Thank you.
Yeah, I've got to be really careful.
I also noticed that on that same rock just to the right of the snail looks like a very small black coral, perhaps.
We'll probably get it on the video afterward. Yeah, I didn't see it. I was thinking of my first joke of the day, and that is that, if you ignore a snail and you're sitting next to Chris, you got to watch out or you're going to get slugged.
Oh, God.
So, sorry about that. Okay, that wasn't even worth waiting for. So we're moving along here. We're still at 2180 meters. And looking for creatures and interesting things to image.
Any of those rocks diagonal up left loose, or do you think they're welded in?
It's just ahead of my tether. It might be, not quite. We'll get there in a second.
Ship should actually be coming to a stop shortly.
Yeah, there's probably a 5-minute delay.
Yeah.
We moved 20 meters, right?
Yep,
Yeah,
that's correct.
Nav bridge move complete.
So, Chris, you had noted there's quite a lot of sediment here, and I know there's a fair amount of sediment also infesting the rocks, and I wonder if this says something about the relative lack of high-speed currents and why that might point to all these dead bamboo corals.
Should
Maybe they were all growing when,
2006
at a time when the
co-pilot, let me
currents were
know how
stronger,
long is the
and they're
swing
not as
time
strong
according to
here,
you.
and for some
Sounds good.
reason,
I'll let you know when I
those
start feeling
do
this way.
better than the bamboo corals. All pure speculation, of course, and it's why we need lots of these sorts of observations along with information on the temperature and the current, the oxygen, to try to tie together what's happening ecologically with why we don't see these communities.
Yeah, and Scott Scott's someone who proposed the site, and he proposed it on the north side of this particular seamount because we do a lot of these sites on sort of the south side here, and generally the prevailing currents out in this area of the Pacific are, at this depth, are tidally driven, and they're moving in a direction from east or northeast a lot of the times. And so I was thinking that this area would be fairly swept of sediment just because the current may be coming from that direction, and sediment wouldn't be carried perhaps as much from the top of the seamount, which is flatter. But so I'm a little surprised to see this much sediment right off the bat. But then we're in kind of a flat saddle area at the beginning of this dive, and we'll see what happens as we go up slope.
Copy that. They're sent on screen, correct? Copy that. Yeah, next one we get to. All right, watch it. I'm going to bump these.
What do you think about those two rocks that were just under the laser? Think there's any hope for that?
Just under laser.
Right, just above the laser right now. Are they attached, or is one of those loose?
Video, quick zoom.
That's attached. All right.
There was one to the. I was waiting for tether, but I believe there might be.
I think I'm starting to move. Go, Nav.
Copy.
So, yeah.
So some of you may be asking, why do we want a rock, for goodness sakes? And I'm hoping that Jonathan Tree, who's the geologist in the chat room right now, could call in and explain what the heck are we collecting rocks for.
From that side, I didn't see any.
Okay.
And Jonathan, I'm going to bug you all day to call in because we haven't had a lot of geologic input on the cruise so far. So I'm hoping that you're going to call in and talk a little bit about the geology at this site.
Yeah.
Jonathan's with the University of Hawaii, the School of Ocean and Earth Science Technology. And he actually was on the cruise with Dr. John Smith here that mapped the seamount. So it's great to have you on chat.
Let's get the same.
It'd be greater still if we had you on
20
audio.
meters, bearing 210, speed 0.2.
20 meters, bearing 210 degrees at 0.2.
Copy.
Yeah, bridge move initiated.
Sure, thanks.
Copy, bridge.
Thanks, video.
So according to that last
You
estimate,
got something on the sandy that's casting a shadow to the lower right.
It's about 5 minutes.
Lower right.
Or is that
Ships
just
are
dead
falling
laying
to where
on
you
the?
can
Is that a shadow, or is
Copy.
that just something dead laying on the ground?
Right, well, next to the lasers now.
Yeah,
Still to right?
right there. No, it's a rock. I'm sorry. I'm seeing
That's all right.
animals. Apologize. So I think Scott's comment about the fact that there might have been stronger current here, and then
There's
in
a
some
small
point in the
stock
past, and then
diagonal
the
up from
sedimentation
lasers.
started coming in
About,
later on.
10
Sedimentation
centimeters
can
tall.
be hazardous to a lot of
He's
these
talking about up
octocorals.
left.
Up left.
Yeah.
It's between those
It's
two
quite
rocks.
possible that there was an increase of sedimentation at the
See what
site
there? Yeah.
at some
Small
point in the
stock, but
past. That
These rocks
did start
might be loose.
um,
Right one looks too big, left one looks
eroding
too
this
small. Though.
community,
You
if
know what I
you
mean?
will.
Yeah, we can go over and see.
The one
Yeah,
all the
there
way
is
at
a
the
possible
top of
black
the screen.
coral on the sediment right to the upper,
Video.
right there above the lasers.
Yeah, copy.
Possible
Thank you.
C-pen, maybe. Never mind.
Possible carnivorous sponge, too. See Chris get excited in the back.
I think he's talking to you because you
All right,
like
video
predation,
man.
Chris. It
You're
is
the sponge one.
That's true, but yeah, so we're both interested for different reasons. Okay,
Sure.
this is not the carnivorous sponge. This is a black coral. And Scott, you want to take a stab at this guy?
Maxim.
You were going to ask that. I believe this may be the genus Heteropathes. And maybe, Chris, you could look it up on the animal guide. I was just going to start to do that before you asked that question. But as you said, it's a black coral, so it's related to the octocorals and the stony corals in the sense that they're all members of the class Anthozoa in the phylum Cnidaria. They're all colonial animals, and the little tentacle-like structures that you see arising from those branches are the tentacles of the polyps. And on these black corals, each of the polyps has 6 tentacles. And so if you look in the center, you count multiples of 6. If you look in the center there, you're going to see a somewhat darker spot. It's like a little tube that's raised, and that's basically the mouth on the tip of a what's called a hypostome. So very small tissue, very small polyps, but apparently are able to feed on. It's a good question, actually, what they're feeding on down here, but in shallow water, they may be feeding on zooplankton. Maybe they're feeding on just organic particulates. There's so much for us to learn about what's going on with these communities in the deep sea and these corals in terms of what their feeding habits actually are.
Great. Thank you, Pilot, and thank you, Scott, for the description.
Sponge
I would
on that
agree. It's
brown rock upper
Heteropathes,
right.
at least from,
Copy.
you know, with my level of
quick,
knowledge,
there's a
I'm pretty
rock.
sure there's an
Like
animal
that.
that matches that appearance,
be
at
loose.
least in the Okeanos Animal Guide, which is online. For those of you who are interested, you can go onto the
That's a nice
Okeanos
size.
website,
Yeah.
and you can find a
Sponge
1,700
one may be loose
image
also.
animal
upper
guide
left.
that is going to be
The one that just went on
updated in the
screenshot,
next
upper
couple
Yeah, I
left.
saw
That
that.
one might be.
I turned away because I
and
thought it
it's
was
going to
big.
grow
Okay.
to 2,900
Play up to you,
images
buddy.
because it has yet to incorporate the Marianas,
Might be
the
frozen
images
in
from
there
the
too.
Mariana Trench
Yeah, it looks big.
and Wake.
Want to look at it?
And then the third version
yeah,
of that
go
guide will come out a while after that, and that'll include the South Pacific imagery that Steve
just looks like
Auschwitz
big to
and
collect.
Amanda Demopoulos and a bunch of people, Matt Jackson and Santiago Herrera were part of, as well as you, Scott.
Alright, but do you want to zoom
Yeah,
in?
Chris, and I would just
Show
say
me
that
sponge,
this is
bud.
such a fantastic edition, and I'm really glad that you spearheaded getting this animal guide together. It's really, really valuable and very helpful. Even if it doesn't give us exact identifications, it allows us to make these comparisons on the fly to things that we've seen
There's
before.
some tiny little dandelion-like sponges on the surface of this rock.
Yeah, so that animal we just looked at, I think, was a sponge. I'm not absolutely positive, and I think it was a hexact. Well, I'm not even sure it was a hexactinellid or glass sponge. But,
Okay.
so what was it? Dandelion?
There are little dandelion-like structures on the side of that rock.
Home.
There's one right between the it was right between the lasers. There's another few of them sort of farther up. Yeah, you see the tips are almost circular.
Oh, there. Oh, okay. So I do think this is a carnivorous sponge, but we're not really sure. We have collected some of these and sent them to the Smithsonian, but I'm not sure anyone has looked at them, and I'm not very good at the demo sponges that the carnivorous cladorhizids are a part of, or members of. But I think we can just put in a guess there that it's a possible demosponge cladorhizidae.
Okay.
It's a very weird form.
Then, well, actually, there was a rock I'm going to show you real quick that I think might be a good candidate.
I think I'm almost done moving, but I got you at 80.
Copy that.
I think
Right above lasers, watch lead. Do you want me to?
Yeah,
try to poke it?
let's take a look. The bigger one or the smaller one?
Unfortunately, the bigger one is way too big.
Yeah, the smaller one's a little flat. That's what I'm a little concerned about.
That's all right. Just want to point it out.
Sure.
There's a lot of rocks down here, so I think we'll be able to find one that you'll be happy with.
Yeah.
All right, Copilot, I'll move ahead.
maybe Charlie.
Yeah, we need to find one that kind of looks a little bit like me these days with a certain amount of girth. So that's what we're looking for.
Another
Well, in contrast to that, we need one that's more
passes
jagged.
Yeah, that's true. And yeah, good point. I'm not that
More
jagged
round.
anymore.
straight
So what
above
is this
lasers,
round
top
bit
of screen.
here on the brown on the lower left of the rock?
Left.
Do you see it?
Enemy or
An
core.
enemy looking guy?
Is that where?
Yeah,
Or
an enemy.
there's something else
Is it
down
an
there too.
anemone? It's an
Yeah,
anemone.
yeah. Let's take a, or it could be a single polyp scleractinian.
All right. Video. Come on
Looks
in.
like an anemone and perhaps another one of the black corals, heteropathes, just below it to the left.
Yeah,
It's a coral. Yeah, see the what do you call it, the calyx?
Tilt down.
Down.
Yeah, and when we finish with this coral, there is a black coral to the left on the sediment, very close to it. And Scott, I thought it looked different than the one that we had imaged earlier, but I'm probably wrong. But we can get a look at that in a moment.
Yeah, I'm not certain, Chris. You know, I've got the 7-second delay, and the video's a little bit stop and start here today, so
No worries.
I can't tell you for sure yet.
Yeah, so this is a single polyp hard coral. So underneath all that tissue there is actually a very hard skeleton. You can kind of see it. It's that whiter, pinker part of it.
In a minute
And
or
it's
so.
a single
Sounds good.
individual
Yeah, I got you
polyp.
at,
So it's not an anemone. It's
85.
actually
Yeah,
something
copy.
like
And there's
related to the shallow,
back a little bit,
hard
but
coral reef
I think pretty
corals
much,
that you see in scuba diving in the
finish the
tropics.
swing, I hope.
So,
Yeah, let me know if you get uncomfortable.
Copy.
So we're good for science here, and then
Great.
it's over to the lower left pilot that we saw something on the sediment there.
Copy that. Lower.
Right. And there it is, directly below and to the center. That's it. I thought this could be something like a Bathopathes, Scott,
Video,
but I'm
come
not.
on in.
It's probably a Heteropathes again.
Yeah, of course, the key to separate the heteropathes and the bathypathes from a distance is how thick it looks in the center along that main stem. But I think you might be right.
Well, you got something in the center, Scott. As your video catches up, it looks like there is a set of smaller branches on the opposite side in the center.
Yeah. Yeah, totally agree, Chris. So that would make those heteropathes. In the bathypathes, you would have polyps down the center there, but you wouldn't have those extra spines or mini pinnules or branches, if you will. So that's another what we saw earlier.
Tilt up. Stopped.
Yeah, so we're good when video is good on that. It's
Video's
one of
clear.
those.
Copy that.
Can we just snap show just below that coral on the top? I think it may have been a carnivorous sponge. Just let science see it.
Yeah, real quick. Snaps him, then I gotta push forward.
It's up.
It is
It's
up.
right below the coral.
Right in here.
Yeah, a little swinging arm on the left.
Oh, very small.
Very small.
In the dark
In
section?
the dark, yeah, copy.
Just
Tilt up.
see
Yeah.
what it is.
Too far.
It's just a pretty small guy.
Same video.
Oh, not something.
Yes, so I would agree with Roland, the videographer, that this is a carnivorous sponge, and it looks like it's got a couple of amphipods on it.
Yeah.
That's what those little crustaceans are.
Are they caught on it, or are they just sort of living there?
I think they live on it. Yeah,
don't
we've
know if
seen
they
this
want
before.
anymore.
We've seen
You
these.
see that, Science?
I think we're good.
Copy.
Thanks very much, Pilot.
All right, I'm going to push real quick.
Yeah, I agree with you, Chris Kelly. I think we've seen those amphipods on these sponges enough that they're not caught by the sponge,
There's
but they're
a new
living
sponge.
associated with the sponge. And I
Sorry,
suspect
I
that
just
the
gotta push
sponge,
ahead
when
a little.
it captures
Catch up with my
zooplankton,
co-pilot real
is
quick.
capturing smaller
Yeah.
individuals than those.
Yeah, thank you, Scott. It looks like Jonathan Tree is going to need some serious prodding here to get on the phone today. Jonathan, I'm not going to... Oh, there's a sponge right there.
Do you want to zoom on this?
Yes, please, if we could. Just snap zoom will be fine.
Yeah, video snap
I
zoom.
think I recognize it. Yep.
Tilt down.
Okay, this is a sponge that I do recognize pretty readily. This is a glass sponge, Hexactinellida, and this particular one is in the genus Euplectella, and it's in the genus, in the family Euplectellidae, and it's in the genus Bolosoma, and so you can
Gotta
tell
do
by the
something
fact
to try
that
to
it's
more
stocked.
stabilized
It's
today.
got a osculum on the top,
Yeah,
and it
just
has a
on a
scooped
rock.
out face on the right-hand side of it. Very distinctive looking sponge, and very common in the deep sea.
Chris, is that stock like a bunch of fibers, or is it just a solid piece?
Video's
It's a
clear.
bunch of fibers
Copy
that are
that.
kind of silicified together to stabilize it a little bit, make it a little bit more durable. So these are actually extremely long spicules or microscopic parts that are modified to form a stalk, and then the very base of it is it's cemented to the rock itself.
All right, Science, are you happy with that?
Yes, we are. Thank you.
Great. Video come wide.
Got some dead stuff, not very interesting, not live stuff. I suppose we could look at some dead stuff that
Oh, there's
might have things on it.
always stuff in the mud, but
Yeah.
yeah, nothing.
That's a dead sponge stock. It used to have something perhaps on top of it when it in its heyday, which was
They had some
perhaps a
potential
long
baby
time ago.
anemones on that sponge. I see some pink stuff.
All right, video, let's do snap zoom.
No, just sediment.
Just sediment.
Yeah.
Copy, come wide.
So when sponges die, they typically sort of accumulate sediment. They lose a lot of their tissue, and they start turning brown. This was probably white when it was alive,
There's got to be a rock in here.
and it no longer has tissue to clear it if sediment gets trapped in amongst the
Might need a
spicules and
rock
skeleton, and
them loose.
they become brown. So it's pretty easy to spot dead sponges
They look all
that are
pretty
still
cemented, though,
attached. Wow, this is a rock. There's got to be something here, Pilot.
If you see anything, I can give it a poke.
So about how big would you be comfortable collecting, just so I have an idea?
So I
what
think
to
like
look
a 20 to 25 centimeter.
Okay.
So maybe like 2.5 widths of the lasers.
Okay.
That's usually a pretty big size for us, but a nice one to grab and take.
Yeah, well, I would agree. These all look kind of cemented here.
Yeah.
So we'll So you didn't want to go for the record? I think it was 154 pounds, I guess.
There's a shrimp in the lower right-hand corner there.
I think that record
Shrimp at the bottom.
Shrimp bottom. Oh yeah.
And these sort of woody stick-like things on the bottom are dead sponges too. They're not actually branches, of course.
Good. All right, video, come on in. I'll back up as we.
Chris, I also wonder if this is an indication that we're starting to move slightly up the slope out of the saddle.
Your mic is closed.
Yeah, just it. It looks like, just looking at the navigation screen, that we're still a bit on the flats here, Scott, for a while. So this shrimp is in the family Nematocarcinidae. It's a long-legged shrimp for obvious reasons. That's what it's called. And these also are common across the Pacific. And there's a number of different species. We're just going to Nematocarcinus, just to the genus, because it's hard to tell species, at least for me. I think Mary Wickstein, who's helped us a lot on the shrimp and other arthropods, might be able to tell what species this is. And there's a little piece of a live sponge there to the left, and that's another glass sponge. That
maybe we'll find a rock in here, Sean.
Yeah, I'm pretty sure I know what that is. I'll go ahead and log it.
And you might find your rock from a higher flight
sponge off to the left, Chris, had an interesting pattern of one living piece growing off the upper right.
Maybe good also
of
to do sort of a side-to-side in this area.
Yeah, so you're right, Scott. It's a Tretopleura, and most of it's dead. It's got one last living part right on the upper side of it. And it's a glass sponge.
Alright, so let's see.
It's a different type than the other ones we've seen.
So that's a starbird.
We'll find one in here, I feel it.
Port.
Okay.
Right there in the middle of the screen, those... Oh, past them.
Yeah, I was just doing a little side-to-side view real quick.
Let's see, where are the lasers? I'm having a hard time seeing the lasers. Are we just too up?
There
we go.
Yeah, there they are. So 2 lasers. I guess that's too big. One of the ones that's just above the lasers. Is that right?
Let's go see. So the one we're on might be okay because it's not 2 to 3 laser lengths all around. So see how it's kind of elongated. I can poke that if you want, but I don't know.
I think it might be stuck though.
Yeah.
Okay, we'll just keep going, and I'm sure the right rock will call to us as we move along. So I'll just talk a little bit why these rocks are so important. If you get a good rock in the right rock, you can find out a whole lot about these seamounts. Geologists are able to date the age of the volcano that formed the seamount. This is a volcano, but it's long since dead. And there is a sponge right there that's a little different to the center left.
All right.
We could get a snap zoom on that one.
Yeah, cut that. All right, video, come on in.
So this sponge is another type of glass sponge. So we've seen several varieties of these. This is in the family Ferriidae, I'm pretty certain. And I would go as far as to say this is likely to be in the genus Polyopogon. There's a whole variety of forms in that genus and a lot of undescribed species out here. But there are certain features, the way it attaches and so forth, that lead to that tentative identification. Yeah. Thank you very much, Pilot. Whenever video is ready.
Go full. Turn lasers off.
Yeah, one time, please.
Co-pilot. Got it.
I was talking about why the rocks are so important.
Video is clear.
Great.
So we're sending these rocks to a laboratory, all the rocks that we collect on this particular project, this 3-year effort that's called Capstone. And we're sending them to the Oregon State University repository.
A slight interruption.
Lasers back on.
That is
Oh wait, just a
being
minute,
run by Dr.
Fernando. I think I
Anthony
got kind of a little
Coppers,
rock wall here
and
situation.
He actually does the technique. He's very experienced and a specialist in the technique of dating rocks. It's called argon dating, and I'm not about to try to explain that, even though he told me about it a bit.
There's a large coral colony to the left.
To the left, copy.
And now, Scott, I think we're getting into higher substrate.
Oh,
yeah, look at that colony.
Yeah, Chris, when I said that earlier, I realized that the map didn't show that we were in a steep slope, but the bottom suddenly had less sediment on the rock, and there was more exposed rock, less area of the sediment between the rocks. So I thought we might start to be climbing at least a small feature, and this definitely looks like a large bamboo coral in the distance. And maybe this is a live version of the ones that we saw broken down
just
below.
turning.
Okay.
Just doing a new.
Yeah, it could be as we get closer.
We'll take a look at this, Fernando, and then we'll talk
I'm a little
about
worried
which way
that a
we'll
lot of
go.
it's dead, but it looks like it's got like tissue on a fair number of the branches.
No, whatever's upslope.
At least near the top.
Just go upslope.
We've got an Anapitherium to the right
An
there as
interesting
well.
question. Oh, there's also a Bassopathes black coral to the right, and we were noting earlier we thought we were looking at a Bassopathes, that classic feather-like appearance.
All right, video.
That rock wall starts.
Yeah, it's interesting. All those broken colonies. You know, you got to wonder. Chris Ma's buddies, the
judging by sonar, I would say that.
that are fond
So,
of
I don't know
preying upon these
how
colonies.
Actually,
comfortable do you
They
feel
start
with
to predation,
After
10 meters
this,
the
or
tissue, and then the skeleton breaks down after that, or if there's something else that is occurring to break up the skeleton. I'm not sure what the answer to that is.
Scott, I think you actually have it, but the wrong critter. If we could
have a
rise a
look real
little
quick,
bit,
then
there's
we'll call an
I thought I
attack.
saw some
Sound good?
apocofrans.
Yep.
Say rise, Watchley.
Yeah, there we are.
Oh,
Yeah,
look
sorry,
at that.
I wasn't suggesting that it was feeding here. I was just talking in general about predation on tissue, removing tissue, and that then leads to the colonies breaking down, so we see the remnants. But yeah, we're looking at a beautiful apocofran mollusk right now, this worm-like snail, and you can see the head end appears to be pointed downwards, I believe.
That's the head.
These are specialist predators of corals.
So are there two of these, Scott, or just one of them here?
Yeah, it looks like there's two, aren't there? Kind of coiled together. One's bigger than the other.
Yeah, I think there's two.
Yeah.
Could this be a
Kind of
reproductive
like a
moment?
periscope. I'll note that you can see very nicely here the bamboo coral is branching from the nodes, and this is something that we would currently put in the genus Isidella, kind of a classic colony morphology of being more or less planar with branches arising from the nodes, and then other details of the taxonomy would depend on the needle-like sclerites. You can see here some of them are very sharp and extend past where the tentacles arise, and you would think that that would be a defense against things like this apocofran mollusk and other predators, but clearly it isn't necessarily effective. Not sure what's going on with that apocofran.
Scott, do these feed on the bamboo corals with radula the way that garden snails might feed on a plant?
Slide down video.
Sorry, I didn't hear the beginning of the question. Yes, they do feed. They do have a radula, just like that snail that we saw moving earlier has a radula, and that's basically a tongue-like structure that's rough. Think of sharp sandpaper, and they can extend that. It's on the top of this very muscular bean-like structure that is extended out of the mouth, and they use it to scrape up whatever sort of food they're feeding on. So in the case of these apocofrans feeding on these corals, and that's one of the key characteristics that lets us know that it's closely related to other mollusks.
Wow. Interesting animals. Thank you.
Okay. Continue on up to the...
So we're now looking at another brittle star living on this coral. And a crinoid. So so the one that we're looking at now, this is a feather star. This is a filter-feeding animal. Basically, it holds its arms out into the water, and there are small hair-like structures it uses to capture food particles as they swim past it. It's attached to the substrate, the coral, with little leg-like extensions called cirri. I also note that there are sort of these white pod-like structures that are present on the what's called the pinnules of the feathers of the arms, and these I think might actually be reproductive structures. So again, this is an echinoderm. This is distantly related to sea stars. These have been around for a long time. We'll see in the fossil record, we'll see animals similar to these with stalks, but we'll often see a lot of them just sort of without stalks on the tips of corals and other high objects taking advantage of water current. So I think we're done with this, unless you guys are imaging more.
Just doing one last full one.
Very good.
We'll move on.
Video's clear.
All right, great. Come wide.
There's another sponge just beyond and to the left of this thing.
Beyond and to the left.
We're kind of going up.
We can do one quick view. It's off the beaten path, but
there's
do a quick one.
Pilot, if you're able to look at that kind of sponge that's to the right center of the screen right now, kind of the tall thing, that's a different sponge we haven't seen today.
Oh,
spiky
yeah,
one.
he's behind the coral. I'm pretty sure I know what it is, but it would be great to do a quick snap zoom to confirm.
Video snap from here.
Yep, that's it. This is yet another form of glass sponge, and this is in the genus Walteria. It's actually related. It's in the same family as the stock sponge that we saw a few minutes ago, but it's in a different genus. And why are these things being put in the same family? Because their taxonomy is based on their microscopic parts, not their morphology so much. And these guys have similar microscopic parts called spicules that allow the sponge taxonomists to put them together in the same family. So thank you very much. That's Walteria. It's like Walteria CF Lucardi is the best guess for it.
All right. Anything else on screen?
I think that's good, unless, Chris, you see anything?
No. I think we can proceed, Pilot. Thank you.
Copy that.
Not a bad sight, Scott. We're seeing a lot of stuff. Except for this little colony that just showed up. Sorry. The little yellow one to the right of the lasers.
Washington, we're doing a quick swap.
Sure, got it.
To it.
While they do that swap, I'd like to throw something out to our sponge specialist. I've noticed that these corals are only moving the slightest amount with the existing current. I saw a couple stock sponges that are sort of weaving back and forth.
I'm sorry, I think there's a starfish on that rock. There's a rock with a dark face that's facing us, and there's a little blip that's on the side there.
Copy, I think I see what you're looking at here.
Our video tech, Annie, has eyes like a hawk, and I appreciate the fact that she caught that for me.
So, Roland, Annie scooped your question. You're going to have to ask a little bit later on. No, that's fine. She's looking out for Chris here and looking for sea stars, and she.
Is it on the left?
Yes, on to the right. There's that dark face of the rock facing us.
Lower.
And there's a.
Yep, it's a little guy.
And then maybe we'll get that sort of orange-shaped coral after that.
Absolutely.
So this is always a good point about exploring the deep sea. Good multiple eyes, team effort, and even though we see a lot of big things, there's a lot of small things as well.
That upper rock.
How on earth did you see that, Annie?
Video can come in.
Wow, that's amazing. So what we're looking at, if I'm not mistaken, this is a...
Emacs zoom right now video.
Yeah.
So this is either a juvenile slime star or another slime star in a separate genus. And what's amazing about that is that the body is transparent. We can see the entire skeletal superstructure inside, right through the body wall.
So Hymenaster would be a good guess?
Yeah, Hymenaster or Hymenaster-like.
Okay. Now we're going to get the...
so we're coming in close.
A little bit closer here.
Yeah, lovely. Seeing these is always a treat.
And actually, Pilot, when you're done with the sea star, that coral that's right above it is the same as the one to the left, so we wouldn't need to go back for that other one.
Yeah, you can see the Well, yeah, I think this is the juvenile of one of the larger slime stars, which we'll hopefully see today. But there are kind of fan-like structures that are supporting the kind of slime-like membrane that covers the surface. And that's what you're seeing there. When they're bigger, the membrane develops, and there's a hole right in the center of the body that they can emit a stream of mucus out through as a defense. Who knows? Maybe we'll get to experience it, and our day will be made. Oh, there we go.
Oh, there it goes.
So that's a hole called the osculum, and that hole is where water enters into and out of this sort of secondary skin that covers over the top of the body wall. And so water will flow in and out of that, as well as mucus when they want to defend themselves.
Coral after this guy.
But that's just beautiful. You can see the spines coming right off of the there are ossicles that create the structures that support the tube foot rows, and you can see the spines that come right off of it. Those are those flanges that look like ribs off to the side. But what we're seeing is just essentially a transparent body wall. It's like one of those invisible see-through man models from the 60s, except it's a see-through starfish. And those brown bits might be the
rotate out?
Yeah, it should be a little bit to the left. I'll try to bring
guts or the gonads. I'm not sure off the top of my head.
For
anyway, thank you. Appreciate it.
Come back in, video. Yeah.
So that's the guy. This is a black coral. Scott, I'm going to tap you to explain what we're looking at here again.
All right, yeah, so this looks like a colony in the genus Mathopathes. Bathy named for depth, so it's a very deep black coral. And we're looking into where those branches all connect as the main stem. And you can see there's a bunch of polyps that run all the way up the main stem. So you can kind of see tentacles on either side. And I believe I may be looking at two polychaete worms tucked into between the tentacles of those. And my image isn't quite so clear. Can you see that, Chris? Especially down towards the lower part of the colony. It looks like there's a scale worm there.
Not just yet. He's trying to see a worm.
I was actually punching this into the log. I'm looking at it right now. Let's see.
Thinks he sees
a worm. The scale worms are very commonly associated with these black corals. It's another one of the reasons we like to have a close look. We can get an identification of the coral, but also see what other kinds of animals are using the coral. And so I can see a slightly greenish-brown discoloration on the lower part. Actually, it looks like two, lower and upper. And I can't
there it is.
Worms in there, or if it's just a trick of the eye.
No, I think you got it, Scott. We can see now what you're talking about. Boy, that's a tough one, because you can see that there are no tentacles right there. The worm is in the center of the tentacles there, and Annie was pointing that out. Man, Annie, what, you have like 10 cups of coffee this morning and you're able to get this stuff? Holy cow. Anyway, good eyes, Scott, to you too.
And little dots that are the mouths of these polyps that are running right up the center of the main stem, the main axis.
Yeah. Great stuff. Yeah, we're good. Good with science there, pilot.
All right.
Let's go to the
Thank you very much for that.
When you're clear video, you can pull one.
Yeah, video's clear.
All right, so our list of species is growing quickly. We have a variety of different glass sponges, and now we've got a couple of black corals. We have a couple of bamboo corals, at least like 3 bamboos already.
You want to take rotator back?
And this is the.
I'll keep it for now.
Copy.
This is the unknown creature. Actually, I call it. Well, I've identified it as a who knows, and I call it who knows 1.
Is that the new genus, Chris?
Yeah, this is it.
Who knows what?
Can you get any tighter? Is that it, video?
That's maximum.
So this is something we've seen in the invertebrate guide. We originally believed that it might be a bryozoan, but bryozoan experts have since sort of said no, that isn't a bryozoan.
Closer to it?
So we don't know what it is, and
not really right now.
One of these days, we'll find out.
That's still going to put the same amount of distance away from your camera.
Watch these. Did you need a closer look at that or not?
I think we're good.
Okay.
Those sure look like lofer 4 tentacles to me, which would suggest bryozoan.
All right, well, this one we could send again to the guy who...
All right, should we get a move it?
Geez, I've forgotten his name, but because I only interacted with him for the first time a number of months ago.
20, yeah.
We can send these to him, and
Do you want
maybe
to
he
center
can
up
confirm.
on
I'll go look up
tiny
who that
rock
is,
hump,
because this is twice
and we'll
I've
just
been
pass
caught
it.
forgetting his name.
I think it's below Sirius
Another
already.
star right of lasers.
All right, we're moving on. We definitely have some more consolidated setup.
2210.
Substrate.
Did Roland say there was another
I think
star?
we're
Roland,
good.
snap. I think this is what Roland's talking about.
I don't know.
There's some stuff.
Pretty sorry star if it's a star.
No, that's just some